Hey everyone, so I'm back. So this is the part 2 of quality way of import and export in ZBrush, part 2. So now we'll be importing the asset that we have earlier, which was our low poly that we created. So I'm going to go ahead to File, New, and go find our 3D asset. In this case is our low poly gear or LP gear. I'll set this to 2K and then import. Now as you see, we have everything we need here. We have all the assets, and as well as we're now going to start baking all the high poly information that we have here in ZBrush and putting it in our low poly. Now, just like I said earlier, I will be demonstrating you the effects of not properly unwrapping it along with the hard edge, and what it looks like if you properly do it and not properly do it, which we have an example here earlier as we go back in our Rhizome UV. When we unwrapped it, is we did not exactly cut these parts out, even if we have the hard edge over here. So we'll be showing you the difference between very cut ones and the non-following ones that we did not cut based on the hard edge. So let me go ahead and start baking. So I'm going to go to Bake Mesh Maps, and I'm going to start importing the output size here, and I'm going to add the high poly gear. So this high poly gear that we have here, this is basically the ones that we created in ZBrush, and we just have to export it out and basically use it as our high poly or high definition mesh that we'll basically be putting information in this model. So let me show you what that does. So here you go. I'm going to go ahead and go to high poly gear. And for now, I'll just play with the default frontal and rear distance. Ooh. Dang. So as you see, there's a lot of artifacts. Now, to fix this is you're going to be needing to configure your rear distance. So to give you an idea what rear and frontal distance does, is that, say example, let me give you a quick sketch in here. Example, your high poly and low poly is in the same location. So this is a good example since I already have both of them here. So let me just subdivide this quickly. So we have both our high poly and our low poly at the same location. So as you notice, the usual tendency is that we're taking all the high poly information and basically use that as our tangent information to shade our low poly to look like a high poly. So that's basically what happened in here, is that it tries to get the high poly information tangent space and putting it in our low poly so it looks like a high poly. But what happened is that, during the calculation, our rear distance did not capture all of the details that it needs. So as you notice, there are things that that did not capture well, and when it's not captured well, it becomes an artifact like you see here. So to fix this information, what you should usually do is I would do this. So say imagine, what rear and frontal distance do. So if you go back here in our Bake Mesh Maps, you see this max and max frontal distance slider. Cancel that, oops. And we also have our rear frontal distance. So I'll be explaining what and how that works. So say example, you have two cages, right? So I have the first cage right here. Okay, let's just try to quickly create this. Don't mind this bad looking cage. Looks like a sunflower. So say imagine you have a cage, right? And this cage is basically casting out rays. So this rays, this is basically, you know, getting all the high poly information and casting it down to your low poly surface. So that's what it does, you know. So let's put that in here. So it's basically putting information, what it sees outside from a bigger cage, it basically casts it down to a smaller surface like the low poly, and basically putting it down as it calculates. So think of it as how light reacts to rendering. So like the raycast rendering or any rendering engine out there, that this is basically the same principles that they do, but the only difference is that it's doing it on tangent space. So it's trying to calculate how light surfaces, or how light basically behaves on a texture or a surface, so that when light actually shines to it, it basically behaves the way how it looks like at the high poly. So it basically gets all the normal or surface information, or the way how it curves on the high poly, and then just basically getting all that information and putting it on our low poly. So as you see here, it basically uses this cage right here to cast down all that information in our low poly. But that's basically what our frontal distance do. So the higher the number of that frontal distance, so the higher you slide on that frontal distance, if you increase it, the more this frontal distance gets bigger. So say example, we have a much more bigger frontal distance. It has more capacity to cover every single area. Now the disadvantages of this is that the bigger the frontal distance area, the less accurate of a placement of a normal map would be. So therefore, that these areas, or these concave areas that you see here, let me just put a different color. So this concave areas become so harder for larger cages, so that, you know, larger cages to be more accurate, since it's much more farther. You know, the farther it is, the lesser accurate it goes to the surface in terms of like casting raycast information to act properly in terms of normal maps. So this is what usually happens. Now if we're going to, you know, now we're going for the rear distance. So what the rear distance does is the opposite way. So if we take a rear distance, so imagine a rear distance, the more you increase that rear distance, the more it shrinks, right? So just imagine the rear distance, instead of scaling, it shrinks as it shrinks as the value goes higher. So the higher the value, the smaller it gets. And the reason of that is that it tries to invertedly calculate any tangents on spaces that the what do you call this, that the high poly can't see, or the frontal distance can't see. So if let's say example, the frontal distance cannot see any concave areas that it can concave areas. It only sees the surface the surface areas. Like what I mean by surface areas is basically the spaces that you see in the middle, and here, here, here. These are surfaces, surface areas, and it can only calculate that area. But what do you call this? What the rear distance cover is basically the edges that the frontal distance cannot cover, which is the edges, you know. So basically, the frontal distance, the rear distance basically covers the areas that you cannot see, which is in this case these areas that is currently having the artifacts. So the more that you increase that rear distance, the more faces or edges, like these parts that did not calculate properly, the more it actually captures it and tries to contain it. So I'll show you guys in a bit more. So if you go back to Substance, so to fix this issue, well, temporarily, is we increase our rear distance. So the more rear distance we have, the more calculation in edges or in concave areas that the frontal distance cannot reach. So if, go ahead and let's go try to recalculate this. So as you can see, you notice that it covers more area. Now it's a little bit more closer. You notice how now we have these edges. It's covering a lot even more space than we thought. It's covering a lot more, right? It's starting to act properly. So it's the same thing even in these areas right here. So I'm gonna go increase my frontal distance, that the areas that the rear distance cannot cover, maybe these areas. So I'm gonna go ahead and increase that a little bit. So you don't want to go overkill and increase everything out, otherwise it's not going to be as accurate. So as you can see, it starts to fix it. It starts to have these proper details, like how it used to look like in our high poly. See? So as you notice, our problems has been slowly, fixing itself. But it's not as clean, of course, but there would be things that you would have to do, such as cleaning the normal map in Photoshop, or cleaning it here internally. So you can try to increase the rear distance and see where it goes, and hopefully it fixes it even more. But you don't want to go too much where it actually tries to even capture other segments that it considers it as artifacts. So you don't want to go too crazy on your rear distance. You don't want to go too crazy as well on your frontal and try to cover as much. You just have to make sure that everything is balanced out. So let's check it again. So there you go. So I think our limit here in terms of bake fix is that we can only fix so much that we cannot even handle this area. So that would be some fixes that you have to do manually in Photoshop. So you can actually export out this normal map by actually going to your library and going to textures. So if you go here to textures, you would see all the bake mesh maps that you have currently been baking, and then you can just basically re-import this back. So as you can see here, this is our bake normal map, and we can just right click and then export this resource. So that's what you can do. Great. So now what we're gonna do, since I feel like this is the only configuration that I feel like this is more cleaner, so what I feel like doing is basically just having to increase the resolution. Since I feel like this is the final version of my bake, or the best of my engine's capability to bake at least this type of object, then I'm just gonna settle for this one and fix any minor artifacts like you saw earlier in Photoshop or in another photo editor. So in here, I'm going to increase this to 4K or 8K. It does not matter if it's a 512 texture, or a 1K texture, or in any other types of texture. You want the highest resolution when it comes to baking, so that even if you reduce it, you're going to have the crispiest photo even on the very lowest resolution. So that's why we always try to bake on a high resolution and try to compress it later and still have the best quality in terms of normal map, even on the lowest resolution. Great. So now you can basically play with this and start texturing this using Substance Painter. So the beauty of this is that you can start really dive into creating wonderful things using this method. You can start creating your own surfaces. You can use smart materials. I can just drag them and have a metal that I can quickly dispose and use, and just tweak it. Alright, look at that. So I'm just gonna maybe probably increase the dirt, or probably I'm going to increase some parts here that I could feel like maybe it's more, that looks better. It's really up to the it's really up to you. But anyway, that's pretty much for proper quality baking. Now let's proceed to the fastest one. Alright, thank you guys so much for watching, and oh, and before that, and as you noticed, you actually noticed that even all of the parts do not have these artifacts, but if you notice that this is the artifact that I was relating to earlier, this is the area that we did not unwrap. So as you can see, if we go back to our normal map, or our UV unwrapping, as you notice, we did not unwrap this, even if we have hard edges on this area. That's why the important thing is that when you guys are dealing with smoothing groups, you have to be very smart where your hard edge is, so that you're not unwrapping every single thing, so that it does not pop up as artifacts. So it's really important that in this certain area, as you notice, you really have to be wise of how you're going to smooth your objects, and only try to basically only try to have hard edge on the areas that you're going to unwrap. Okay, so in here, if you go back, we did not unwrap these, right? We did not unwrap those, so now it's having these hard edged artifacts, because naturally Substance Painter or any programs do not know how to calculate hard edge. That's by nature. So what you could do to fix this is you only have to hard edge the parts that where the seam lines are. So the trick is, when you're dealing with artifacts such as these that have hard edge artifacts, to fix this, you could try to smooth everything, and then when you start unwrapping your object, try to select all the edges that of the every single island of your model, and then try to just have it on a hard edge. Give me a moment, sorry about that. Alright, so as you notice, like I said, you have to be wise with where you put your hard edge and where you put your smooth edge. So say if you're making a model, be wise on where you're going to unwrap it and how you're going to plan your smoothing groups, and you'll have a much better looking bake and without any artifacts. So as you notice, it's minimal. There's no even there's no to the slightest in terms of artifacts, because we planned it very well. So as you notice here, this one is much more noticeable compared to other things that we see here. We can't even see any artifacts on other objects. So I hope you understand why we have to always plan our smoothing groups properly in order to get the best results in our baking. Would you look at that? See the difference? Anyway, thank you guys so much for watching. So in the next episode, we'll be doing the fast ones and how we could speed up our workflow when it comes to baking and dealing with high poly. Alright, take care guys. Bye.